Hi everyone. In this video, I'd like to talk a little bit about a light-based Morse code communication system and demonstrate a simple LabVIEW based VI that I'm working on. The motivation behind developing this project was mainly to introduce a new and simple communication protocol that can be easily developed over LabVIEW. And hopefully, by the end of this project, you'll have a more comprehensive understanding of some of the core design patterns that we use in LabVIEW. And you also get a chance to play with the code for yourself and sort of self explore a lot of very interesting topics that are going to come up here. So, Morse code is a rather old communication method that was mostly used in telegrams to send and receive messages in the pre internet age. Using a series of dots and dashes, one could essentially encode all the alphabets and characters and then transmit them via electrical lines. These characters could then be decoded on the receiver end to complete the whole communication chain. The rules for Morse code are very simple. A dot is usually interpreted as an on signal for one time unit. A dash is an on signal for three time units. Spaces between dots or dashes for the same alphabet are usually 1 unit long. Letters are spaced three time units apart, and words are usually spaced about 7 units apart. Once the signal is converted into a Morse based code word, using the rules that I just mentioned to you, what we can do is we can essentially look up the corresponding English data words and then decode the original signal. The hardware requirements for this project are really very minimal. You can pretty much make do with just an LED and an LDR or a photoresistor. But to make things a little bit more interesting, we also require you to display your messages over an LCD screen as well. Before I go on to show you a demo, I'd just like to take a minute and talk a little bit about LiFi for those of you who are curious. So, LiFi is a relatively new visible light communication system that is actually capable of transferring information almost 100 times faster than Wi Fi. It's also a whole lot cheaper because, like you guys are going to see when you build your own projects, it essentially only really requires an LED, a driver circuit, and a photo detection system to really work. That said, one of the obvious disadvantages that LiFi really faces is that since it's a visible light communication protocol, visible light can't really penetrate through opaque objects. So its applications are mostly limited to the tens of meters range, like short range applications. If you are curious about the technology, I think a good place to start would be to follow the link that I've mentioned over here. Okay, now I'd like to do a small demonstration of my VI. Now, before I show you the demo, I'd just like to say that this is by no means an easy project. So I would really recommend that you take some time out and think through your implementation beforehand. And also think about the information that you may need to store and the design patterns that may be useful to you. You may also want to relax some of the timing rules, especially for the receiver design, so that you can allow for the possibility of human error when tapping in the messages. Yeah, just feel free to change and experiment with whatever timing values work best for you. Okay, first I'd like to go over the receiver design with you. So let me start tapping in a code, okay? So let's say I do So one thing that I want you guys to notice is that as soon as I hit the 3 time unit mark, it automatically decoded the alphabet and it moved on to the next character. And also notice that the LCD both displays the Morse code word and also the decoded data word. Now the transmitter design should be rather more straightforward. If I enter my message over here and then I press the send button, it should automatically start sending in my message using the LED. And also the LCD screen should not only display the data word that we're sending in, but also like the code word that is being sent by the LED at that moment in time. And that's really all there is to this project, honestly. There's really nothing much more to discuss. I think one great feature about this project is that it can really be extended in all sorts of ways to actually comprehensively study communications protocols. In fact, if you're clever about your design, you may also be actually able to replace the more obsolete Morse code with, more communication, more current and relevant techniques such as ASCII tables and Unicode tables. And then you can even like try things like, minimizing the bit error rate or performing error correction or a whole host of other important like communication concepts that, that can be built just using this simple interface. Um, I think another great thing about this project is you can even try to experiment with sort of deciphering and deploying your own commands. So I could type in something like, LED on, and you can try to sort of decode this message, and you can actually try to turn the LED on, or maybe turn a fan on, or like a servo 150 degrees, or whatever information you actually send can actually be processed and can be implemented. So I think that's another very interesting idea that you can develop on if you want to further your own understanding of this project. So yeah, good luck and have fun building your own designs.